Am I audible?
Yes, sir.
Yeah, thank you.
Audible, sir. Good morning. Good afternoon, sir.
So in the last class, we were seeing the internetworking devices, right? The cables, modems we didn't see. We have seen the repeaters, hubs, switches, and the network interface cards, right? And today we will see bridges, routers, and the gateways. Okay, so this is we have finished till here, like physical and the data link layer. Only the repeaters hubs we have finished, and the network interface card also, and the bridges we yet to start. So in this figure, you can see the bridge will cover the both the layers, data link layer and the physical layers, and the routers will be having the three layers: network layer, data, and the physical layers, right? So I'll just go through the slides. Network interface cards we have seen basic functionalities working, and the MAC address, right? So till here we were seeing the complete the network interface card, right? The internal structure, what and all will be there, and how the frame will be formed using the source MAC address, destination MAC address, and anyway we will be sending this complete data through the Ethernet, right? And there are two types of Ethernet, 08 and 00, correct? And the actual data we have appended here, and along with that there is a CRC or the checksum, right? So these are the two different techniques used to detect and correct the errors involved in the data packets. So this complete structure they call the frame, right? In the data link layer, frame there is go. Now, and for that network interface card is identified using the 40-bit number, 48 bits numbers, and it has the total 6 bytes, right? And the starting 3 byte is identified as a organizational unique identifier, and the remaining 3 bytes, that is the network interface controller identifier, right? So now we'll see the bridges, right? So as we have seen in the first slide, the bridges will operate in both the layers. So here it is a TCP/IP model, right? Why TCP/IP? Because it has only the 5 layers, right? Application layer, transport layer, and network layer, data link layer, and finally the physical layer, right? So the data will be flowing like this. Then this is the intermediary node, or here as we are studying the bridges, you can say this is the bridge, right? So the data will be going here, then from there it will be coming here, then this is the destination. So this is the destination, and the source, if you consider the data flow will be like this. And in the application layer, the data will be in the form of messages, right? And in the transport layer, the data will be in the form of segments. The same data will be referred as the segments. And in the network layer, it's a packet. Correct? And in the data link layer, it's a frame. right? And in the physical layer, it's just a bits, right? And these bits will be converted into signal, like this will be coming. Then again here it will convert bits signals into bits. Then again the bits into the signals, like this will be going. Then again here zeros are 1, zeros are 1. So like this it will be there, right? So now we are considering only this device. So this is the intermediary device which works or which operates in the physical layer as well as in the data link layers. So the bridges can divide a large network into smaller segments, and they contain the logic that allows them to keep the traffic on each segment separate, right? And when a frame, so here we cannot say the packet, right? So when a frame enters the bridge, and the bridge not only regenerates the signal but checks the destination address and forwards the new copy only to the segment and address belonging. See here, the compared to the hub and the repeaters, very good distinguish feature the bridge has is the one is it is a very intelligent. It knows the where exactly that frame is going, right? So it can identify the source and the destination address, right? As well as the port number also, correct? So that's why they have written here the bridge not only regenerates, means the at the beginning I was talking about the regenerators or the repeaters, right? So what it does, suppose this is a system, one system sending to a information to the another system here, right? So this is the link. So as this is the signal, so as it is reaches here, so the signal's strength will go down, correct? And we cannot recognize the which one is the 0 and which one is the 1, right? In order to make a strength, or in order to increase the amplitude, or in order to sustain the information which was sent by the source S to the destination D, we usually used to use the repeaters, correct? So what it does, it will just repeat the repeat the bits, right? Whatever the bits was there here, so it will repeat it, eh, or regenerate the original signal, then it will send to the destination. So the same functions will be carried in the bridges as well. That's why here I have written the regeneration, right? So regeneration of the signal, original signal, and as along with that it checks the destination address where the frame has to reach, right? And the regenerated frame will be sent to a address which it is belongs to, right? Yeah, in this figure you can see the two different LANs are there, right? So this is the one LAN, you can see the LAN 1, and this is the LAN 2, right? So these two LANs are connected via a bridge, right? Via a bridge. So and whatever the suppose A wants to send some information to D, so no need of the bridge, right? So it can directly send the information to it, so no issue in there. But A, suppose it wants to send to the data to the node G, then we need a bridge, right? Because this is the different network, this is the different network, and this is the different network. In the same, I mean, what I want to say, the different LAN, not a, no, I'm sorry, not a different network, same network will be there, right? But different LANs. So LAN 1 and LAN 2, both are in the same network. For example, in our our TT building, right? So different labs will be there, correct? So each lab will be having this LAN connection setup, correct? So for example, this is a communication network lab, and the other one is, you can say, the some other lab, for example, the automotive, the which is there in the 7th floor, automotive engineering lab, correct? And these two LANs are connected via the bridge, and both are having the same network, not a different network, same network, right? So yeah, as I said, the bridges operates in both the physical and the data link layer. So what in the physical layer it has to do, and what the bridge has to do in the data link layer, right? So as I mentioned here, so the regeneration of the original signal, so that is the function it will carries at the physical layer, right? The bridges which is available in the physical layer, so its function is to regenerate the original signal. And the second layer is the data link layers, right? So in the data link layer, what bridge has to do here, I'll come back to there. So here I had mentioned that it will send the packet frame to a particular destinations. So how it has to do? Using the destination address, right? So that is the MAC address. So the data link layer, the bridges, what it has to do is it will check the MAC address of the source and the destination which is available in the frame. So depending upon this address only, the bridges will forward the packet to a particular node or the device. So the another specialty in the bridge is the filtering capability, right? So it will filter the unnecessary data which is sent to the other devices, correct? So in the previous class I was telling like the hub, right? Hub will transmit the data to each and every nodes or the devices which are available in a LAN, because the hubs was not having the capacity or not having the intelligence of detecting the source and the destination address, correct? So here in the bridge it has the capacity, or it has the ability to check the source and the destination address, right? So as a result, it will send to only the destination which has mentioned in the frame, right? It won't send to the all the nodes. So for example, in this figure, right? So A has to send to the G, correct? So suppose if you are using the hub here, we can use hub here, right? If you are using the hub, right? So what it does, it will send to all the nodes which are available here. All the nodes will receive the packet which is sent by A. But in the bridge case, what happens is the bridge will forward that packet only to the G, because in the frame we have the destination address, that is the physical or the MAC address of the device G. Right? So that's how we can filter the unnecessary broadcasting of the frames in the network. And if the frame is to be forwarded, then the decision must specify the port, right? So in this in this image here, right? So this is the one port, and this is the another port, and this is the another, and this is the another. So these are the ports, right? So suppose the bridge has to send the destination packet to the frame, I mean sorry, to device G, then it has to go through this port, right? So this port number also the bridge should know, correct? That's why here it's saying that if the frame is to be forwarded, the decision must specify the port also. A bridge does not change the physical MAC addresses in a frame, right? So the bridge functionality is not to change the MAC address. Only the MAC address will be changed by the NIC, network interface card. If you are using the different network interface card, then only we can change the network interface card, right? But in the bridges, no, we cannot do it, correct? Because see in this yeah, here only the MAC address will be there here, correct? Or I'll go to the next one. Yeah, here, right? So this is the device A. So in the device A, all the layers will be there, correct? This is the device A, and this is the device B, right? And this is the bridge. This is the bridge, correct? This bridge doesn't have any accessibility of changing the MAC address of the device A or device B. It can only read the MAC address or the physical address of the A and B, but it doesn't have the capability to change these MAC addresses. So a bridge has a table used in filtering decision. So that's what I was mentioned here. So it has the MAC address and it has the port address, correct? So these all things where it has to store, correct? So some space or something should be there where we can store these informations. So on demand we can provide these informations, right? So that's how we are having the tables here, right? We are having the table A at the bridge A. So this is the source and the destination, right? And source has to send the data to the D, and this bridge will be having the addresses. These addresses are, what are these addresses? These are the MAC addresses, are the physical addresses, and this port are these things. So this is the port number, this is the port, right? So in the bridge we'll be having this, right? So this is the one port and this is the other. So here they have mentioned the port of the bridges, not the port of the devices, right? So suppose here, so MAC address of this device, so this is the A or B and C and D. Suppose these are the 4 devices are there, correct? So and these 4 devices are connected. So this is the LAN 1 and LAN 2. So again I'm telling these two LAN 1 and LAN 2 are not different networks. These are the same networks, but they are different LANs, and both are connected via bridges, right? And in the bridge, what should be there? The table, and this table gives the complete information about the LAN 1 and the LAN 2. What are the devices are connected to the bridge 1 with the port number 2. So here port number 2, you can see here port number 2, and these are the MAC addresses which are available here. And similarly the port number 1 of the bridge and the number of devices which are connected to the bridge of the port number 1 are indicated here. So using this table, the bridge will forward the information, right? So in the bridges, we are having 4 different bridges: simple, multi-port, transparent, and the learning bridge. So in the simple bridge, what happens is the addresses, right? These addresses are there, right? MAC addresses and the port numbers. So these are manually the particular person has to enter in the table, right? So here third party should be available, right? And whenever there is a one more new station is added, or one station is not working, right? Or the one device is not working and we need to remove it, right? Again we need to manually modify the table, right? And installation maintenance of simple bridges are time consuming and potentially more trouble then the cost savings are worth, right? So it's a time con because it's manually need to be updated and manually need to be addresses and the port numbers need to be added, and the manually we need to add new devices, or if you want to remove the new. So these are all, you know, time consuming, right? And this is not good idea to have this kind of a bridge in the network, right? And the second one is the multi-port bridges, right? So as it gives the information, the bridges will be having the more than one ports, right? 1, 2, 3, 4, like that's many numbers, right? So here you can see the bridge is there, and this has the, for example, 3 ports, 1, 2, and 3. So 3 different LANs are connected through the bridges. So this we call the multi-port bridge, right? But again, the disadvantages is like, as we, you know, connect a more number of bridges, like we, if you increase the scalability, then the traffic, right, the collision, right? So these all will be the problem for this kind of. So it's like a centralized system, right? If something goes wrong to the bridge, right, then complete all the LANs which are connected to the bridge will never share the information. So that's the one of the issue which has a multiple bridges. And the transparent bridges. So in the transparent are the learning bridge builds its table of station addresses on its own as it performs its bridge functions, right? So they will be, you know, the coding in such a way that it will learn on itself and it will build its own table, right? So if a transparent bridge is added or removed from the system, reconfiguration of systems is unnecessary, right? A transparent bridge must meet the following criteria. So the first criteria is frames must be forwarded from one station to another, and the forwarding table is automatically made by learning frame movements in the network, right? So one LAN is there, right? Suppose this is a LAN A and another LAN B, right? And one more LAN C, right? And these three will be connected through the bridge. So like this, correct? So 1, 2, and 3. So I'll consider only 3 systems here. So A, and here one more will be there, B, and here C, right? So at the bridge, right? So at the bridge we will be having the table, right? So we can say the forwarding table, correct? So here addresses will be there, and here port numbers will be there, correct? So suppose the A is the physical address and B is the physical address and C, and the port address, right? 1, 2, and 3, right? So this table will be created when the information will be sent to all the 3, right? So for example, at initially how it will be, right? So initially nothing will be there, address and the port, initially nothing. Suppose A wants to send the data, A wants to send data to B, right? So at that time only the table will be updated. So A is the physical address and the port number is connected to 1, and B is the physical address and port number connected to 2. Only this information will be there, because the you know, it has to learn on its own whenever there is a frame circulation in the network. Suppose B wants to send the data to C. At that time, right, we are having already A and B physical address and port number. So at this time we will be having this table, final table, right? And suppose one more device we have added here, D, correct? So A wants to send data to D. Correct. So at this time, again, the one more row will be created. So their physical address is D and port address will be 3. Same, right? So like this, it will keeps on updating the forwarding table of a bridge. So this is about the transparent bridge, the third one. The last one is the learning bridge 4. Right. So the learning bridge. So again, the same kind of structure they have considered LAN 1, LAN 2, LAN 3, right? So originally, nothing will be there, right? And after A sends, right? So the same thing, whatever explanation I have given here, the same thing is there here also, right? So the transparent bridge and the learning bridge both are same. Not this is not a fourth one. Both are same only, right? Because here I have written transparent or the learning bridge builds its table of station addresses on its own, right? See, this is the initial, and A wants to send after A sends a frame to D, right? A to D. So there is a updation. So bridge will get to know that the address of the uh, device A and the port A. And after E sends a frame to A, right? So E to A. So it will get to know the physical address, I mean MAC address and the port address. And after B sends a frame to C, right? So B will be sending frame to C. So like this. So whichever the devices are the station will send the data at that time. This table, this forwarding table will get updated on its own. So that's why they are calling as the learning bridge, right? So in the learning bridge, there is a problem called the loop problem. Let's see how the loop problem will be there. So in the transparent bridge, work fine as long as there are no redundant bridges in the systems, right? So they here this is the simple bridge, so no issue. There is no another connection here. Suppose the one more bridge is there, right? Only one bridge I have connected. Suppose one more bridge is there and it's connected like this, right? So if you connect like this, so this is the bridge 1 and this is the bridge 2. So suppose LAN 1 wants to, I mean the A wants to send the data to the D, right? So what happens? The bridge will receive the information as well as the bridge 2 also will receive the information, right? And bridge 2 will send the information here and bridge 1 will also send the information here. So the same information will be sent twice, right? So here also one time and here also second, here also one time and here also second time, right? So this is the, if we are having this kind of a structure or the network of the bridges connection, then that we call the redundant bridges in the system, right? Yeah, that's what they are saying. So in this case, if the bridges are transparent bridges, they may create a loop, right? Which means a packet may be going round and round from one LAN to another and back again to the first LAN. And to solve this kind of a problem, so we are having two solutions. One is the spanning tree algorithm and another one is the source routing, right? So let's see the what is this problem it is, right? Okay, here only I'll explain because here okay. So in here, so station A is there, station B, station C, station D, and our objective is to send the information from station A, right? This is the source, to station D, correct? And two LANs are there, and we are having the two bridges, bridge 1 and bridge 2, correct? So the address port of the bridge and address and port of the bridge, initially it is 0, 0, nothing will be there. And when the source A will send the data frame. So what it should be there? One is the payload, actual payload means actual data, and the source address in the destination physical address or the MAC address, right? And when it reaches here, so it will be what? It will just sending, right? So it will be going here as well as here, this packet. So both the side will come, correct? And as a result, so both forwarding table will be get updated with the physical address of the A and the port number. So A, right? And the same informations again has a in the frame it is there, the destination is the D, right? So bridge what it does, it will send the information to D like this, and the bridge 2 also it will send the information to D. So we are getting the two copies of the frame and LAN 2, the same information, right? So same information will be coming to D twice, correct? So and here again the D will be sending back to the information to the A, right? So D will be, so here D is there and D will be sending back information to the A. So both bridge will again will receive the information and it will be going back, right? So here it's a complete the loop, correct? So whatever the information we will be sending, it will be circulating here only, right? So how to avoid this looping concept and the problem? So that's the main challenge, uh, main challenge in the bridge, right? So in order to solve that, we are having the spanning tree and the source routing. So for today's class, I won't take spanning tree and the source routing because it requires a lot of time. So I'll just in the next class I will tell about that spanning tree algorithm. So how to solve that and how to get the shortest path from source to the destination. Right. So now we'll see the routers, right? So as we have seen the whatever the things we have seen, one is the repeaters we have seen and hubs, right? Then the second one we have seen the switches, right? And network interface cards. Then what we have seen, the bridges, different bridges we have seen. Now we will see the routers, right? So router will be there in the network layer, right? So here the router will be there, correct? So in the router there are three layers: physical layer, data link layer, and the network layers, right? So its main function is to two networks are there. Suppose the network A and network B. In order to establish a communication between these two networks, then only we need the router. Otherwise, we no need any router concept here. Okay. Suppose if you are sending the data within the network A, then no need only the routers or the bridges, right, or the switches or the repeaters. Only those things only we need. So in general, what I will write is this is the one network A, right? In the network A, we'll be having the hubs, correct? Repeaters, bridges, switches, SWL, right? Switch, and last one network interface card. So these all devices will be efficiently can work only within the network. And suppose if you want to send some information from this network to this network, right? So we need a router. So router we need. So this is the router, right? because we need to identify the network. Where is the network B? It is right. So here you can see. So this is the one kind of a network. So a ring network, and you can say this is the bus topology. Again the ring, again here ring and the bus, right? So this is the one network, network A, right? And this is the network B, and this is network C, and similarly this is network D, and finally this is the network E, right? So here very nicely they have represented. So in order to make a connection or the communication link or the connection establishment, that will happen only through the router. Here also router is there. So this can communicate with this only through this router, and this network D wants to communicate to the network C. This will happen only this router, and this to this router, and this to this router, right? So here the how to identify the network, right? So that again here one more address will be there, that we call the IP addressing, internet protocol addressing, right? So this is of the 32 bits, right? So in detail we will see in the network layer what it is, how it is, or what and all will be there. Like the way we discuss the bridges, the similar kind of functionalities even the router will be having. In the router also we will be having the routing table, right? The IP addresses will be there here. Instead of the physical address and the port number, here the IP addresses and the port numbers will be there, right? So this is the actually comparison between the hub, switch, and the router. So hub is a broadcast device. Whatever the information will be there, so everybody will be receiving that information. And in the switch, it's a multicast, means only the selected devices will receive the messages, right? So that is the switch can do. And the router is used for the routing the packet, right, to a particular device. And hub works in the physical layer of the OSI model, physical layer or the TCP/IP model, right? And the switches will work in the data link layer and the network layer of the OSI. So here they have considered the three-way switch, right? So there are many switches, two-way and the three-way switches. So whenever we say three-way, so data link layer and the network layers will be there. And if you consider the two-way switches, then the physical and the data link layers will be there, right? And the router will be there only in the network layers. And hub is used to connect devices to the same network. Yeah, this is very important. It can connect devices within the network or the same network. The switch is used to connect devices to the network, right? But a router used to connect two different networks, right? I showed you, right? Network A and network 2 in order to establish connection. So there we need the router. And hub sends the data in the form of bits, right? Because it's in the physical layer, and the switch sends the data in the form of frames, okay, because it will be in the data link layer. And the router sends the data in the form of packets. I at the beginning only I told, right? In the application layer it's a message, and in the transport layer it's a segment, and in the network layer it's a packet, and in the data link layer it's a frame, and in the physical layer it's a bits. And hub works in half duplex, right? So at a time both cannot speak, right? So the device A can send the data and wait, then device B will send the data and wait, and again he can send. So like this way. But in the switch, it will be like at a time both can send like this. full duplex in the switch. And similarly, the router will also works full duplex. At a time, both can send. And only one device can send the data at a time. That's what the half duplex it is. So it's kind of a repetition. Both half duplex means one at a time, and full duplex multiple devices can send at a time. And hub does not store any MAC addresses of a node in the network, but switch stores IP address and the MAC address of a nodes. Similarly, the router stores IP address and the MAC addresses of nodes. So here they have considered the three-way switch. If you consider the two-way switch, only the MAC address will be there, right? So the gateway potentially operate in all the 7 layers of the OSI model. So this is how it will look. So earlier it used to be like 1, 2, and 3, right? Only this much the router used to be. Then this is like a switch, two-way switch at the bridges, and the hub and the repeaters will be like this, right? So it's a gateway, all the 7 layers will be there. So actually what it does is, whenever we say we want to send the data from one layer or one network to the another network, suppose this network is using the different protocols and this network is using the different protocol. So in order to understand, in order to convert this protocols information into this protocol information, so we need some kind of a converter. So the gateway will do accepting whatever the format it is there in this protocol, and that format will be converted back into the protocol which is running here. This is what today's class. So any doubts?
No, sir.
Okay.
No, sir.
Okay, thank you.